Okay, here we are with assignment 7D. This is going to be the washer or disc method. And so what is kind of important is this. The axes of rotation, like if it's a horizontal axis, you need to set up your equations as a dx. All right, so that means you're going to have things like, x squared plus 3x or something like that. Okay, you need to set up your integrals as a dx kind of style. If you have a vertical axis of rotation, okay, if you have a vertical axis, then you have to set up your equations as dy. So that would be like y squared minus 3y kind of idea. Again, one more time about how to set things up. And here we are given two different things. To set up these volumes, let me get a fresh page here. A fresh page. A volume is going to be pi r squared. Okay, so we'll assume that we are going to be doing this dx. And so I think the new idea of today is that we are going to have two different radii, and you have to individually square them. And I'll explain what this means here in just one sec here. All right, so that is like this. Okay, so let's say that, yes, we are rotating about the x-axis. It's all good. So this is going to be a dx kind of style. And I have this, but I don't want this entire area. I only want the area between this and this. I want to rotate this area described right here. Okay, I don't want the entire area, but rather just the area described in between these two curves. All right, what these radii are, again, in this formula is this is the big radius and this is the small radius. And what this radius is referring to is from the axes of rotation. So here we're rotating it about the x-axis. So what's the furthest thing from that x-axis? Well, that would be the purple. And what's the smallest thing? Oh, that'd be the blue. So I would take this purple equation, square it, and subtract the blue equation, and square it, and then integrate that result. And that's how you handle an area in between two different things. And again, because this is rotated about the x-axis or a horizontal axis, this is a dx. We'll learn a different method here eventually, but this is, yeah, just the pi r squared method. So big radius minus a little radius. Now, if the axes were up here, again, we'll describe how to move these around here, I think later on. The big radius would be the blue, and the little radius would be the purple if we move the axes. It's still horizontal, so it's still a dx, but you have to watch out what is the furthest thing, what's the big radius and what's the little radius from where it's being rotated. Okay. So here we go. We have this area described right here. We are going about the x, so this is going to be a dx type of rotation. And so let's just check on the calculator here real quick just to make sure I know what we're talking about here. So I have an x squared, I have an x to the fifth. I'm assuming that this is at 1, 1. This is what I'm really kind of looking for. And so I'm going to go zoom fit. Yeah, so this is the x to the 5th graph, and this is the x squared graph. I'll kind of color coordinate. So x to the 5th is this one right here. Okay, that's the x to the 5th. And then the x squared is this one right here. So about the axes of rotation, which is this guy right here, the big radius is the red, the small radius is the blue. So the area goes, excuse me, start this all over again. So the volume is going to be pi. This area starts at 0 and goes to 1 of the big radius, which is the furthest one, that's the red one. So that's going to be the x squared minus the little radius, which is the x to the 5th squared dx. So you square the individual radius, not everything all together, the individual radius. All right, so this is x to the 4th minus x to the 10th, and the rest is just kind of math there. So again, running through this, this is the pi integral from a to b of the big radius squared minus the little radius squared. Okay, so here we're going to move this about the line of x is equal to 5. I'll explain how to do that. And again, for a better explanation, this is going to be coming in a couple different lessons. I believe it is assignment F that we are talking about more of these manipulations of these movements. I'll speak briefly about it, but again, for a better explanation and more practice, take a look at assignment F. All right, so this is going to be y is equal to plus and minus the square root of x, and x is equal to 4. All right, so here we go. So we have this y squared. We also have x is equal to 4. So the area encapsulated is this right here. And we are going about the line of x is equal to 5. Okay, so this is a vertical axis. So this is a dy type of integration because we're integrating side to side. All right, so what we notice is that the big radius is the red radius, and the small radius is the blue radius. Okay. So this is what we're going to do. Okay, so I don't need this equation engine. Didn't need that. So we're doing this dy. So we have to have y's. So x's are equal to, in essence. Okay, so this top floor is 2. This bottom floor is -2. Again, I'm coming this way because we're doing it dy style. So x's are equal to dy style. So bottom to top. All right, so this is going to be a volume of pi integral from -2 to 2. Okay, of the big radius. And so the big radius is the parabola. So that's going to be the y squared. And I'll come back to the manipulation here in just one moment. And then the little radius is straight up the number 4 squared uy. All right, so for my axes of rotation, the big radius is the y squared, the little radius is the 4. How to move the axes, and again, a better explanation is in is in assignment F. Take a look at it. So what we see here is that the new radius is 4. So what I simplistically, the new radius is 5. So what I simplistically do is I subtract off that new radius from each side. If you ever see this in like a multiple choice, people always do it the other way around. They take like 5 minus the other way, because most of the time that provides a positive number. But what I'm saying is, long story short, this provides a difference, and ultimately this is being squared anyways. So whether the difference is positive or negative, if you square it, you'll always get a difference squared, which is always going to be a positive number no matter what. So I don't really, this is just to simplistically do it. I subtract off the new axes of rotation at the end. You have to be a little bit more careful when it comes to the shell method, but that's what it is. Okay, so let's do some math here. This is going to be what? Y to the 4th minus 10y squared plus 25. And this is going to be minus -1 squared, so 1. So this is going to be y to the 4th minus 10y squared plus 24, right there. All right, so here we go. And the -2 will get the exact same answer, but that's a negative. It does. All right. Okay, so this is going about the x-axis, so that means this needs to be a dx kind of method from 0 to 3. Let's figure out where this intersection occurs. Oh, I think I remember this problem. Yeah, they're sneaky. So this intersection occurs at a value of 2. All right, so, but notice how our interval goes from 0 to, they want it to stop at x is equal to 3. Okay, so we have 2 different areas described here. Okay, we have this area from 0 to 2, where it's blue over red, And then we have this area from 2 to 3, and where it's red over blue. All right, so we have to be very careful about how we rotate this. So what we're going to have to do is we're going to have to set this up as two separate integrals. Okay, let's talk about the area from 0 to 2. Let's rotate that, and that's going to be the blue over the red. So that volume of that, I'll call it volume 1, is of the left-hand portion, and that is going to be pi integral from 0 to 2 of the blue, which is negative x squared plus 2x plus 5, over the red, which is x squared plus 1. All right, so there's going to be some math going on here. I gotta write this out. I'm not super up to speed when it comes to like the pyramid and Pascal's triangle and stuff like that. All right, so this is going to be a positive x to the 4th minus 2x to the 3rd minus 5x squared, negative 2x to the 3rd plus 4x squared plus 10x. And this is going to be negative 5x to the squared plus 10x plus 25. And so this ultimately is going to be x to the 4th minus 4x to the 3rd minus 1x squared plus 20x plus 25. Okay, that's that portion of the problem. And then this portion is going to be x to the 4th plus 2x squared plus 1. Because it's negative, it will be negative x to the 4th minus 2x squared minus 1. And so ultimately, this polynomial that is going to be the resultant of these is going to be x to the 4th drop. So this will be a negative 4x to the 3rd, negative 3x squared plus 20x plus 24. Okay. Oh, shoot, that's not the entire answer. I'm sorry. That is just the answer. Oh, good. Just the 0 to 2 volume. I'm sorry. I shouldn't have scored that up. All right, so that is the volume of 0 to 2. I'll put it right there for right now. And then we need to complete this by finding the volume of the other part, which is going to be the volume from 2 to 3. And that is going to be the red over the blue. All right, now, good news. subtraction is going to be the exact same thing as the subtraction that I did right there. Okay, it's going to be the exact same, however, it's going to be the exact opposite. So I can steal that answer, but it's going to be the exact opposite. So this is going to be 4x to the third plus 3x squared minus 20x minus 24. I promise you. Okay. It's going to be the exact same difference, but just opposite. Okay, so that'll kind of speed up this process just a little bit here. So x to the fourth, x to the third, 10x squared, and 24x. This is going from 2 to 3. Okay, so we start this off with the 3. And then 2. Okay, and so that is the volume of that sliver that is on the right-hand side from the 2 to the 3. Or, yeah, from the 2 to the 3. Okay, so we have this volume left and volume right. So all that's left is to put these two volumes together. And so the volume in this situation is going to be 64 pi plus 10 pi. That's going to be 74 pi. We find the area of region 1 about x is equal to 0. X is equal to 0 is a dy sort of mentality. So region 1 is just a big radius, and that's about it. And it is of this line, which is y is equal to x, or aka x is equal to y. So this one is set up perfectly, not a big deal at all. So this is going to be pi integral, okay, because it's dy, it's going to go 0 to 1 of the big radius, which is y squared dy. Okay, I'm going to set up these volumes, and you can answer them later. Okay, so area 2, about y is equal to 0. The y is equal to 0 is this axis right here. That's y is equal to 0, so this is going to be dx. So area 2 has a big radius and it has a small radius. So this is going to be pi from the area begins at 0, goes to 1, the big radius, which is x, minus the little radius, which is the curve, which is x squared dx. And I'll worry about solving all this stuff later. Okay, this one is going, next one is going about x is equal to 0. So again, this is going to be dy, and this is about region 3. So the big radius is technically an equation that they don't even give, which is technically x is equal to 1 is the big radius. And the little radius of this is the curve, which they give you there, which is going to be x is equal to the square root of y. That's that equation written for a dy kind of method right there. So this is going to be the integral from 0 to 1 of the big radius, which is 1, minus, actually not 1 minus, it'll be 1 squared minus the little radius, which again was the square root of y squared dy. Because it's going about the x is equal to 0, or aka the y-axis. Okay, next problem is doing the same axes. Okay, again, it's still x is equal to 0, so that's still a dy kind of method. And we are doing region 2. So here the big radius is the parabola, and the little radius is the line. So this is going to be pi integral 0 to 1 of the big radius, which is the parabola, which is the square root of y squared minus the little radius, which is the line, which is y squared dy. So that's going to be 1 minus 0, so this is going to just be 1/3. So let me do that one more time. I dislike it when I don't complete all the problems with all the technicalities, so this is 1 minus 0. All right, so this is going to be x squared minus x to the 4th. I feel like I already did this problem. Yeah, there it is. Oh, I didn't. No. so we have y is equal to the square root of x is equal to 4, and and y is equal to 0. Around the x-axis, so this is going to be a dx style. So this should be pretty, okay, so we're going to divide this into two parts. Okay. So what we do is we first begin by finding the grand volume of this entire thing. And so the grand volume of this entire operation right now is going to be pi integral from 0 to 4 of this region, which is going to be what? The square root of the x squared dx. All right, so, yep. And so this is just going to be x. So this is going to be 1/2 x squared. This is 16 minus 0. So half of that is 8. Okay, so that is the area, or excuse me, that is the volume. Okay, so now what we're asked to do is we are asked to construct another volume of the same parameters, except we need to find a x value that splits the volume right in half. So what we're doing is we're coming up with some sort of x value that when we rotate that or the other part, it doesn't really matter, it will be exactly half of the volume. So when upon this rotation, this is going to be equal to 4 pi for the volume, half of the current volume. Okay, so to set that up, this is going to be the integral from 0 to, we'll call it, I'm not going to call it x, I'm going to make it a different letter. I'm going to call it the letter A. Okay, the letter A. So this is going to be the A of the square root of x squared dx. Right, so we're going to find this, and then this volume is going to be equal to 4 pi. So that will tell us what A is. So again, this is going to be x, 0 to A. So this is 1/2 x squared. So this is going to be a squared minus 0. And this is all consistently equal to 4 pi. Okay, so here is our math problem right here. So what we're going to do is we're going to divide by pi and multiply by 2. And then square root that, A is going to be equal to the plus or minus 2 square root 2. Now, because this has to be in the interval from 0 to 4, okay, the negative portion of that answer doesn't make any sense. So the x value, aka our A, is equal to 2 square root 2. That is that x value that will split that volume right in half.